FRP is a topic that has come up many times during PDX-Funk's life, but it's kind of funny how every time we encounter it, we look at it in a very different way, using different tools and so on. So I'm looking forward to seeing what your take on it is.
Well, thanks. Yeah, I've been interested in functional reactive programming for a long time, but haven't really taken the time to delve into it until recently. But I did read about 10 years ago that book by Paul Hudak on the Haskell School of Expression. It's a really fun book, and that's how I learned Haskell to begin with. And that's kind of the beginnings of functional reactive programming. The idea is that we want our systems to be as declarative as possible, and oftentimes things can be represented as continuous signals or a series of events, and there's a little bit of tension between those two. So events being discrete things that happen at particular points in time, and then we have continuous signals that can be used to represent things like the movement of objects in physical systems, or an audio signal or a video signal. And sometimes we want the events to influence what happens with the continuous signals. So there have been various ways of handling this. And I saw a similarity between commercial software called Max MSP and functional reactive programming. But the functional reactive programming that's been studied in the academic field has been, there's been some really interesting results, but it's not necessarily been that accessible to people who haven't been able to read the papers. And I'm getting to a point where it's getting easier for me to understand what's going on in the papers, where I can pick up another one and say, oh yeah, I know what they're talking about, and not spend as much time befuddled over it. So I'm feeling like I'm just getting oriented. I was hoping to give a talk where I'd have everything sliced and diced for you and make it all clear, but it's going to be a little bit more of a walkthrough and showing you some of the things that I've looked at so far. I do have all the systems I talked about running on this computer, so I can actually demonstrate things. It'll be fun. So we'll talk a little bit about the systems that I'm going to demonstrate. Yeah, Bart? Oh, yeah, I can make that. Yeah, that's no problem. Yeah, that's just the kind of thing that happens to be sitting on the screen, and I didn't necessarily want to be distracted with it yet. But is that good?
You guys have the lights off too?
That's fine.
Do you want to turn that thing on?
So I read a survey paper about functional reactive programming, and it seemed to me that there were a few different approaches going on, and two systems that came up a lot that were mentioned were FRTime and Yampa. FRTime is implemented on top of Scheme in a system called Dr. Racket. Racket is, most of you are probably somewhat familiar with Scheme. If not, then it's a Lisp. It's Lisp 1, what they call it. There's Lisp 1 and Lisp 2.
It's a stripped down Lisp.
Yeah. So it's a simplified version of Lisp. And Racket is as well. Racket has object-oriented programming and a lot of GUI stuff added in. It's designed to teach people programming. And within this Racket framework, this Dr. Racket, you can actually run a lot of different languages. So actually, let me bring that up.
Like other schemes or Lisps or?
Well, let's see. Can I make that bigger? It doesn't look like I can make that text. It's much bigger.
For example.
The languages you can choose in Racket include how to design programs, which goes along with the book. There are various different levels of
I see what you mean.
Scheme, like simplified, like really simplified versions of Scheme. There's lazy racket. Algol 60 apparently is the language that they've thrown in there. And FRTime, which is like I said, that's the functional reactive programming extensions to Scheme. So it's actually based on Scheme rather than based on Racket. And I don't even know what these other languages are. Well, R5RS is Scheme. But, anyway, so the Racket system is pretty neat. It's got this interpreter where you can, or reval print loop where you can actually output things like little icons. You can have values that are graphics in the output in the replica. With FRTime, you can output values that change over time. So, for example, seconds is a changing value. So, I'm sorry that that's a little bit small. I don't know if I can blow that up, but that's just a number that's increasing per second. I'll be able to throw a magnifying glass on this window. It's not following the Mac user interface guidelines. Let's see.
Is there a magical hotkey combination that just zooms on the entire screen on that?
Yeah, there's zoom.
Control and scroll.
Yes.
Control scroll.
Yeah, hold that control and scroll.
Oh, let's see.
Let's see.
Oh. Oh, there's a font thing in here. Dr. Racket, maybe.
Yeah, I'm more familiar.
Yeah.
Just take our word for it that the
Yeah.
number is changing.
Yeah. And then you can type milliseconds, and that is the number that changes a lot faster.
Woo! Look at that go.
So there's this concept in functional reactive programming in some of the literature of having continuous signals versus discrete events, things that change us at particular points. FRTime seems to, even though you might think this is a continuous signal, it's really, it's all based on, everything you write is based on seconds or based on milliseconds, and these things are just updated at a certain polling interval. So there isn't a real notion of continuous change in FRTime. But now I can make a function based on seconds, so I can say times seconds 2, and now it's double the other number always, and it keeps changing. So what they've done is they've essentially overloaded this times operation in FRTime so that it can operate on these behaviors. In FRTime, they use some terminology that's a little bit different than some of the other functional reactive programming systems. The terminology is completely standard. So I can show you the terminology in this document. This is at racketlang.org. They talk about behaviors as sort of an umbrella term that covers events and signals. So events are supposed to be discrete and signals are continuous. But like I said, because of the implication, signals aren't really continuous. And events, I've noticed that events and signals in FRTime are they're not as different from each other as you might expect them to be. They're very easily interconvertible. So there's a function called, let's see, changes. So changes is a function that you can call it on a signal, and it will give you an event. The idea is that it returns an event source that changes, or it fires an event every time the value changes. Well, what does that mean? If you had a continuous signal, that wouldn't make any sense. If you have, let's say, a sine wave, can you fire an event at every instantaneous moment? Change. But you don't. But you're not fully continuous here. What you have is something that's changing at some delta time, like the millisecond value is changing at some delta time. So it does actually change a little bit, and then you just at every one of those fine grained time periods, you get an event finder. No, just the value of the signal, I think. But there is another thing to get the delta. There's something called derivative. If you want to get the change from one moment to the next, you call it derivative on it. If you want to sum it up over time, you call it integral. So I could say integral on the time. What's that for time?
One of the things that makes this very difficult is the term continuous building and discrete time processing.
Yeah.
And you got to be careful in reading documentation stuff about which they're talking about.
Yeah. Yeah. Yeah, when I talk about YAMP, I'll talk a little bit more about what their notions are. So ideally, what you really want to do with changes is you want to have some function of your time. Like maybe if time is less than 5, then 0, else 1. And then it makes sense to call changes on that, because now you've turned it into a stepwise function. So I could say, or I could say if seconds less than 134.733.0750. Oh yeah, I can't write less than in the infix. Actually, you can. I think in FRTime, I think you could put a dot. This is or it's a general thing in Racket that lets you put a dot around the operator to write it in infix notation. Oh, okay. All right, let's add 30 more seconds. Trying to remember my scheme. Oh, it doesn't like that, so I'm just going to say. I had the parentheses in the wrong spot.
No, I think why did you say you reference the global seconds and
Okay, so that's a 0 now, and then when it, can I reference the global seconds? It is the global. Yeah, see, it changed to 1. So.
What if you want to, that makes sense, if you say, I want value seconds right now, I don't want
Yes.
to change.
Yep. Yeah, it's value now, seconds.
You can use that.
Yeah, so I could subtract, I could do seconds minus value now, seconds.
What if you say changes?
What's that?
What if you say
Changes milliseconds? Yeah, I think that kind of crashes it. It's already getting a little bit overloaded. The other thing that, oh, no, it's actually working. So the way it prints out events is it only, this is saving us because it's only showing us the most recent event. Even though the event is really some stream of events, the way it prints it out is only the most recent. The other, one thing that sucks is when you get to the end of the screen and you start scrolling, it will want to scroll back up so it can update these things instead of just scrolling off the screen and hiding them. So it gets to be really unwieldy and you have to stop and start over again. There's also a hold, so that this is if you have an event and you want to turn it into a quote-unquote continuous stream. So events come in every once in a while. Maybe you get a 1 here, you get a 5 there. Hold transfers it into a continuous stream. So now we get an event 1, we hold on to that value until we see the next event, and we hold on to that value, and so on. So you can easily convert back and forth between the events and signals. Another nice thing about FRTime They also have things like, well, collect that do accumulation, arbitrary accumulations. Yeah, there's a lift provided for things that aren't already lifted for you into that into FRTime. Yeah, so one nice thing is they actually have a wrapper around their GUI calls for FRTime. I haven't really experimented with this yet, so I can't show you, but all of these values, like the border, the spacing, the min height, all these values can vary over time. And then there are events provided for some of these things, like a button.
So is this both input
So you
and
can,
output? So for example,
yeah, it's both input and output.
input with I'm going to pull for the second so I can display a clock, and output in the sense that as I resize the window, functions depending on those values get updated.
Resizing the window.
Or at least
I'm not
like
sure.
an input field.
I'm not sure about resizing the window, but I know that there are input fields, there are buttons and things like that do provide input.
Well,
Why are all those things duplicated?
Oh, because this is some. It's like a symbol that
keyword.
a keyword. Yeah, and this is the value.
Got
It's just also, if you're curious, this /C, anything with a /C is really a type declaration. So those are constraints. The C stands for constraint, and they have a constraint system in here that allows you to or a contract. I'm sorry, it's called contract. So it's reminiscent of Eiffel's contracts. It's not a strong type system, but it allows you to say, well, this function has to return something of this type, and it's a runtime check. If the function doesn't return something of that type, you get an error. Yeah. Yeah, so you can declare those out of band. You can declare a function, and then later you can say /C something, or is a CFG message, or is an integer, or integer /C. And you can add those constraints later. So yeah, I think that's pretty much all I have to show in there. I do have some text that I wrote up about FRTime.
So actually, to backtrack real quickly,
Yeah.
so being able to add the constraints later would be useful for things like dynamic programming?
Dynamic programming.
As in, you're building up a new custom function.
No.
Not that kind.
Oh, okay. Sorry.
Thank you, Bart. Sorry.
Yeah.
So
Questions?
can I ask a stupid sort of scenario? So
Yeah.
if I have all these functions that sort of the value they return depends on
Mm-hmm.
the time of day, how do I call those functions? Why is this still functional programming?
That's a good question.
Well, but they don't explicitly necessarily miss them. They don't look like you have to have seconds in everything.
It's not a pure functional language that's requiring you to do everything
So this
functionally,
is reactive
but
programming language, really, but that's okay.
it's in the same sense that Scheme would normally say, yeah, it's okay.
Well, no, but there is a pure functional subset of scheme. And
Yeah, there is. Actually,
it's part of it or not.
I think they tweaked Racket so that by default, when you do cons, it creates an immutable con cell. You actually have to call mcons to make a mutable one.
This is a really good idea. If you ever
Yeah.
do that. But, as somebody who's done it both ways. Yeah, okay. So there's nothing magic going on. There's some no-name thing where they say, oh, no. If you wave your hand, you stare up this way. It's obviously still
No, it's just that, like, well, what's the functional style to, like, write functions that operate on values and return results without changing anything? So the idea is here we have some, you know, sort of continuous value, and then we're writing some pure function that's transforming it.
Sure. I mean,
It's functional
except
in
that
that
it
sense.
isn't maybe a pure function with the first and these things. So you could certainly write a pure functional style. I mean, the referential transparency matters when it's only as it makes yourself better. That's totally
Yeah. No, no. I think I covered everything. Oh, another interesting thing they have is view cell and set cell. So they actually have some references that can hold on to values that are part of this FRTime system.
So what is a cell?
It's like a reference, like
Sorry,
or
what's
a
a
pointer.
reference?
Like you create a box and then you have a pointer to it. And you can change the value that's in the box.
Okay.
So explicitly not functional.
So here's a different
Yeah.
What kind of program is this user write?
Mhm.
Why would I want to do that?
Mm. Yeah.
Should we expand that to FRP now?
Yeah, sure.
Yeah. But why is it easier? Why is making programming easier? That's the question.
Something happens during each frame.
Mhm. Well, I think the goal of me for programming is to make it as declarative as possible. I want to think about I want the programming to work in the way that I think about the problem. And I think there are certain kinds of problems, like for example, we can see more of audio processing, where it's very natural for people to think about the problem in terms of like streams of data and then doing non-destructive calculations on them. And it's just models that way that people think about it. So instead of doing something like imperative programming in C++, where now I have to put it in this bucket, now I have to add this value, now I have to put it in that bucket.
Similar ways, but the thing that I find compelling about FRP is that it helps you eliminate redundant state. Because if there's this piece of state that is a function of these other pieces of state, traditionally in a non-functional environment, you have to then put little pieces of code at every time you modify the other pieces of state that recalculates the state. If you can just kind of, in a reactive way. But the problem that I find though, just using it for things that work well with it in a larger system is that it's sort of starts to take over all of the system because then every value has to be a reactive value so that people doesn't control the whole thing. Mm-hmm. So it's very difficult to use really useful in the system. Not really
But
reactive is it unrelated?
oh,
You certainly do the same kind of things in lazy programming, right? So we're all going to
mm-hmm. Yeah. It's related because it has to do with laziness is demand driven. The thing is, some functional reactive programming is demand driven, and some of it's eager or force driven, I guess.
It's like used by especially, but you see a lot these days on browser, like you find which kind of browser you like, and like you do like model binding things where you say this UI element is bound to the value of this the view is bound to this element in the model, and whenever that changes, it updates the UI. Not you have to say when this changes,
Mhm.
That's get through, and also you can have like pseudo model attributes. So this pseudo attribute is the computation of these other attributes, and then everything is kind of eventless in their style, or will everything will automatically go correctly depending on whatever.
Yeah, that is one desired goal. It's like letting things automatically recalculate when you set them up. So instead of having to set up a loop where you're going through and doing things at every iteration of the loop is sort of out there in the framework and abstract it out, and you can focus on the relationships between the values. That's essentially what these are, pipes and filters. Yeah. Except you have to be concerned with like how the control flow works. You can have problems with control flow if you don't set things up right. So like pipes on the Unix command line are very much akin to lazy evaluation in Haskell. But I'm sure if you use them enough, you've seen it stall when you didn't expect it to, because something is waiting for something, and that was waiting on the other thing, and it wasn't processing. So
Yeah, but that's not like
no, it's not. But like, it's a very simple model of like the Unix command line is a very simple model of pipes and filters that won't handle all the situations that we need to handle here. But yeah, it's not. There is a general concept of pipes and filters, and it's very much fits into that. But yeah, control flow is important, and I would like to. So should I do Yampa or Max? I'd rather.
One thing to backtrack on. When Julian and Kingsley talked about FRP the last time, which was a while ago,
Yeah.
a lot of the examples he showed were from kernel elements, kind of the glue of this thing, and they seemed to be almost exclusively things that reminded me of things like Flash, as in the Macromedia, Adobe Flash type things, where the goal was to display some kind of visual representation, and the core of the program was pretty much following a timeline and having the UI tied to that timeline. So as you progress through the program, you would update the position of all the different things. And I think, and again, I don't understand this as well as some of the rest of you, but the impression I got was what made it valuable was, the court's question of when is this useful, is if you're building some kind of interactive game, the tracking things like time becomes very important, and that has the potential of simplifying. Whereas if you're doing more general purpose programming, that's not quite
Okay.
Argue with me if you want, please.
Why don't you think of an example of word terminal showing the small software where he had with these little UI elements that would be tied to continuous signals like an or whatever, and they would use some JavaScript to render that continuous signal to some visual element.
Yeah, there are many systems related to this. So I'd like to go on and show Max MSP and then show Yampa at the end. Max MSP is really fun to look at. So this is a commercial product which was originally designed for manipulating MIDI information, so controlling audio, but discrete audio events. And it's called Max. It's from a company called Cycling 74. Later on, as computers got faster, they realized, we can add digital signal processing capability to this. So when they added that, called it MSP for Max Signal Processing. So the core part of Max is just this discrete events that get passed around, and they're processed in an entirely synchronous manner. And the MSP is for digital audio processing. And then they added another component called jitter, which is for video processing. But I'm not going to go into that. I don't think we'll learn anything extra from that. But Max is a lot of fun because you draw all these little diagrams. This one is, I'll show you that in a bit. I figured out how to do factorial, and it took me forever to figure that out. Yeah, it's definitely geared towards certain sorts of things. So it's really helpful to look at some of the tutorial stuff. So these boxes with numbers on them, those are input boxes where you can type a number in. And there's a sort of basic event in Max called bang. And it's just sort of the...
You guys in the back see what's part?
There's a graph.
Yeah. Yeah.
Does someone know how to activate?
Yeah, I can make this bigger. No, this I can make bigger.
Okay, cool.
This is actually user interface guidelines. But
Yeah. Tell us when you can read your part.
yeah.
Aww.
No, it's fine. Yeah. Yeah, so I can put a number in here, and then it propagates through. And then this box is called an object box. Print is one kind of object that prints something out, and there's another window where this comes out, and you can see the printouts. It's called the max window. So you see at the end it says result 1.000. That's the thing that I just printed. So what happened is when I entered the number, I hit return, and it propagated the message 1 to this box, and that propagated the message 1 to that box. So it's both setting the number in the box and propagating. So each of these little boxes in Max is essentially like a little object in an object-oriented system. And it can have multiple inputs on it, and you can think of each of those inputs as a different message that, well, you can actually have different messages you can send to one input. So there are certain messages that can go to one input. If it has multiple inputs, there's certain messages you can send to the other input. And when you send the input, it can store information. You can store internal state, and it can also output values. So it's essentially mapped to objects and object-oriented programming. You can also manipulate, besides integers and words, you can manipulate lists just by putting spaces between things. So these are lists of numbers, and there are special objects that let you process lists and use stacks and things like that. So these are message boxes, the ones that are dark like that. You can't
Can you
edit
read the
them.
contents for those?
What?
Can you read the contents real quickly for the stuff I can read?
It's like 22. I mean, it's
Okay.
sort of irrelevant. They're just numbers.
Yeah.
Yeah. This one says my dog has $1 fleas, and that means $1 is the first argument. So you see this other box that's leading into it, and if I put a number and then it sends the message 5 to this box, it plugs in the 5 for $1, and then sends the message my dog has 5 fleas through this line, and then it's going to print that out. So here it is. My dog has 5 fleas.
Okay.
And here's the list of numbers that we printed. So the message boxes, you can't edit them, but you just click on them and they send their message. Or you can trigger them by sending a bang to them. Or sending, in this case, this one got triggered by sending, when this box sent its message 5 to this box, it triggered this one to send its message.
So how do you set those?
How do I set what? The message boxes? Oh, you have to go to edit mode. So there's a lock down here, and you unlock it, and now I can click on this and edit it. So it's sort of like design time and runtime. When I lock it, it's runtime. Although it is actually still running when you're in design mode. It's just that the buttons don't necessarily all operate the same way, because like this is a button, and if I click on it, it sends a message, a bang message. But if I'm in edit mode and I click on it, then I'm just editing it. I'm no longer sending a message. There's also something called a metro, which is a timer. I can bring up the Object Explorer. So let's put a metro out here, and I wanted to pulse every 2 seconds. So every 2 seconds, it's going to send a bang message. And I can put print box down there. And then I wire them up to each other. You notice when I mouse over this, it's got a little circle around it, and then I can drag my line down and go. Oops. That happens because I have segmented patch codes for none. Okay, so so now I put it in run mode, and we go to what was that window? Max window. Oh, it's not working.
Confused with maximizing.
Right. Huh.
What is the number?
Oh, that's because I didn't start the metronome. It's not active. I have to. What was the question?
I guess that's one. Depends to them.
I'll put a toggle up there. Okay. So now I'll turn it on. That sent a bang to the metro, and now every 2 seconds it prints bang because metro sends out the message bang. And it's going to the print box.
So to actually repeat Life's question, what exactly is, so we've got print at the bottom of all these. How does that work?
How does it work?
So is print at the bottom just, that means that it's the
It just
end of
means
the
it goes
chain
to
and
this
it's-
max
okay,
window. It's pretty bugging, really.
got it. So for example, at the things up on the left, what it's just doing is, for example, printing and turning it into an integer and then printing that to the max window when it changes, right?
Yeah.
Okay. I'm guessing you click on one of those options at the top and that
Oh.
activates it?
So yeah, if I click that, it sent the message 25
Okay.
into here, and then it printed out the 25. Or hey, I hit hey, and now it should have an error because that wasn't convertible to a float. See,
Uh-huh.
Phonum doesn't understand hey. Phonum is what they call a float. And because I sent that message, it's like, I can't print that out as a float. Well, actually, this box is a Phonum box, so the error came when it sent that message to this box. You can't process it. And then if I click that, the toggle off, it stops bringing out bang every 2 seconds.
I think the next linker are not continuous signals for messages. So
Yeah,
right now, there's nothing happening between the toggle and the metro. When you fix it, then
Yeah.
so you could have a bunch of different toggles, right? And that will all send messages. Whatever the most recent one.
There's like things like sliders.
yeah. There's sliders. Whenever you move the slider, it sends a message as you move it. And there's another box that lets you, that you can put it after the slider that says, don't send a message until they let go of the slider instead of sending one continuously as they're sliding it.
It's not quite continuous. It's probably
No.
No, it's not continuous. This is not. Yeah, it's not really continuous. None of this Mac stuff is not continuous at all. They're discrete events, and furthermore, they have a particular ordering, which can be cause for consternation. So these events are not sent out simultaneously. So you can route, let's say, out of this button, I've got 3 wires coming out of it into 3 other buttons. Now, when the button receives I can make this bigger too.
So is the top always an input and the bottom always an output? Because
No, you can wire them in each direction you want.
Well, because it's got that thing on the bottom. Like, oh, okay.
We're not. My instinct is that
Yeah.
that's going to be an infinite loop.
It is an infinite loop, yes.
Because
Yeah, you look at a stack overflow on the bottom line. So it's a call stack. Well, I mentioned that these are like objects in an object-oriented programming language, right? So when an object makes a call to another object, it pushes that call on the stack, and then that calls another object. So whenever you're sending a message, it's pushing that on the stack.
So the frames for these proxies that you like,
Yes.
wow. Well, how does it do input? There's no return. There's no return from the message. I think it's basically stacked purely to avoid.
No. No, it's the stack calls them infinite. It doesn't avoid them.
Well, but I mean, if you weren't counting the times, the things you sent a message.
It doesn't return data back, but it returns control back.
Right. So, yeah. So it can go down the next.
Yeah. So it does a depth first traversal when you send these messages.
This is significantly different. Like it seems the same superficially to like a GStreamer work, but with a GStreamer, like everything between elements has got to activates like a scheduler that actually decides how to synchronize when it does things in order to meet timelines. Because everything, like you're playing back audio or video, you want to make sure that the audio stream is synchronized with the video stream, and they, video is like in frames and audio is in, like milliseconds.
Right.
Like the units are like completely different and have like way different timing, but they have to like be synchronized still. So it has. Like conceptually, it's like you do this and then you throw it out the output to the next thing you handle. But internally, like between you and like the next thing is actually like this it's going into a scheduler that actually decides what to do.
Okay. Yeah, I'm not familiar with GStreamer, but I'll look into that.
So maybe literally this thing is that. So
Hello, Dr. Racket just crashed.
Did you solve that?
Yeah.
Yeah. So when I click one of these boxes, basically, when I click on a box, basically.
Yeah, you can watch the debugger. See?
Yeah.
Um,
Why is it really
So much.
That's just a visual.
it's just to help you slow down so you can see what's happening.
Oh, okay.
So yeah, it does propagate down to the bottom. And so if that graph converged somehow, then you would get multiple
Messages.
loops
Yeah.
multiple times.
Yes.
So,
Yes.
And
So
so that's
that's-
a loop that would get stuck and would never get down to
Yes.
the bottom.
Yeah. So that's the loop at the bottom, and it
So
gets stuck.
that is cool. Are you on that?
I can. Just give me a second. It doesn't matter which one I click on either.
Nice.
Yeah.
Let's see what that does with the screencasting software.
Stack
So,
Overflow.
Stack Overflow.
Outputs are
You
disabled.
could do that at GStreamer.
Until this message is cleared.
Well, so with a continuous system as opposed to a discrete, in theory, that loop would be just fine. At each tick,
Well,
it would just run to whatever the current position is.
no, that actually calls. So I haven't discussed Yampa, but
Okay.
it depends on. So in Yampa, there's different switches that you can set up. If it's not a delayed switch, then you would get it in a different loop. If it's a delayed switch, you want.
Mhm.
The delayed switch is infinitesimally delayed. So let's see. Yeah, so the weird thing is the messages, it passages, if you have three or if you have multiple outputs, then it sends them right to left and then bottom to top, which sounds backwards of what I would think, but that's how it works. And so I was wondering, if you can't make cycles, but maybe you sort of can make cycles. Is it possible to construct a factorial out of this? Oh, and Bart, what you were saying about having multiple messages go in, this could be a problem in theory. Let's say you have one of these boxes that's like times 1. So there's a left input and a right input, and the idea is, well, you could have just a times by itself or a plus. If I had just a times, then the left input and the right input get multiplied together. But, so the 1 can be changed by the right input. 1 is just an initial value for this box. And if a new number comes in on the right input, it changes this argument internally. It doesn't show anything different on the screen, but it changes its state so that the 1 has a different value. And then when something comes in on the left, it outputs a new product. Also, if I mouse over these inputs, you see this circle is red and this circle is blue. Those are called hot and cold inputs. Cold input, when you send a value into it, it changes the internal state of the object, but it doesn't trigger it to output anything. And the hot input, when you send a message to that, it actually outputs a new value. And that solves this problem of if you want to update both sides, and if it's sent an output each time, you might get some intermediate multiplication that you didn't intend. So because
you specify that?
no, they're built into the components. They're all designed like that.
Sorry, it's not. I mean, it's that component has that.
Yeah, that component, it's part of its nature.
Yeah.
Yeah, to be hot on one side. So the idea is since the messages are sent from left to right, right to left. That's why the cold ones are on the right and the one all the way on the left is the hot one. So the idea is you update all the input values from right to left, and then when you hit the one on the left, it would actually trigger the calculation.
So you can have like a metronome as a clock signal to like.
Yeah. And so I wanted to figure out a way to do factorial, and this actually works. If I put in, you can see it already says 720. I think I put, this is a like debug breakpoint that I put in so we can see what happens. Oh, sorry, I have to turn it on. You can actually watch it go around. It'll change at some point. It's just because that output is left from the previous calculation.
Well, that's what's
It's about to change, I think.
Is
No,
that
it
a cold
didn't.
input then to that register?
No, that's a hot input. I'm surprised it hasn't changed yet, actually.
Right, that's what I was
There's also a debug window that shows you like what messages are being sent. So this says the sender is number, the receiver is times. Oh, whoops.
Looks like this hasn't updated the view yet or something. Oh, probably.
Maybe.
Same.
So the idea of this setup is that you put your input up here. And then,
There, now it says 120.
oh, cool. Yeah. Yeah. So if I wasn't running the debugger, we just instantaneously calculate it. But the idea is this is not this is more an iterative solution, not a recursive solution. So this is just an accumulator that, or this holds on to this number but counts down. So when we put a 5 in, it sets this to 5. But then it will keep counting down because we subtract 1 and then feed that back into itself. And then this little conditional, which is a little bit more wordy than you might expect, but if the input is greater than 0, then $1. So it's sending a message if its input is greater than 0, but if its input is not greater than 0, it suppresses the message. So that causes us to keep decrementing. And then every time it decrements, it also sends an output over here, and this is the right channel, so that it sends a message here before it sends a message here. And this one starts out with a 1, so it's times 1. But remember that this argument can be updated. So that becomes an accumulator that keeps storing the product. And then multiplies each of these values by the accumulated.
So does it have some kind of reset that resets it back to 1?
Yeah, that's what I put this up here for. So when you put a number in up here, it sends a message to this message box, and this message box, anytime it gets any message, it outputs a 1.
But, well, no.
So the 1 goes down to here, and resets this to 1.
I meant as far as like the times 1. So is it actually updating that to 1 and then feeding it back through into the cold thing?
I guess it was
Yes, yes it is.
Okay. So that's how it's setting that back to 1.
Yep.
Okay.
Yeah. Yep. Yeah. The 1 comes in here, and then it feeds it back through to here, so it turns to 1 again. Yeah. This is the last thing I added in there, just to reset it. So there are lots of different. There are other ways that you could write
Is there any kind of like race
this,
condition?
because it almost feels like cheating to have all these words in here to me, but.
Is there any kind of race condition as far as like the countdown from the other side getting in there?
There's no race condition because it's completely synchronous. It's completely deterministic.
Well, I mean, like, did you have to like make sure that something like had a step in there to make sure that it didn't like start?
So like if you took that one message box and dragged it over to the left, that would change the order the messages go out in, and that might screw it up, right?
Yeah.
Yeah.
Yeah, and what matters is where the destination is. It's not like how the wires are routed, but like where the two destination boxes are located relative to each other.
Can we try that as an experiment? Move the one message box over to the top left of the 5 and then type in.
This one?
Message box.
So
the right one.
Oh, this one?
Yeah, if you move that to the top left of the 5.
Oh, yeah.
Wouldn't that screw that up?
Yeah.
So if you ever wanted to know what the opposite of preferential transparency
Yeah.
we are here.
Oh, that's not what I meant to do. I meant to remove the watch point. Run through the debugger. So that should mess it up. Ooh, now we get a 1 as a result.
See, the 1 is sent very last, so it does all the
Oh,
work,
yeah.
and then
Yep,
sends
and
the
then it sends a 1, which, yep.
one.
Yeah, so that's what I don't like about Macs.
I don't understand why.
The programmer was using their native language is ancient Berber, which the writing system is bottom to top, right to left.
Yeah.
Yeah.
So what's even better than this?
Sorry.
But what's even better than this is somebody wrote some patches, because you can define sort of sub patches. So you can make a patch and then give it all a name, and it has it's like a module. It has an input or multiple inputs on it, and then it has outputs. And so someone made ones that are called define, call, recurse, and you can actually. I have this in a file that should be already open. Or here's call. Don't ask me to explain it because I haven't understood it myself, but it basically uses stacks to store the arguments. The interesting thing is the thing that uses it, which is define. Oh my lord.
The thing we're going to talk about is the audience for Macs is musicians, not programmers.
Okay.
And it's actually, I think, a really interesting example of, I mean, it's done a lot of the similar things that Excel has done to the business world, to the music world.
I don't know where I put them.
It's not designed to be.
I like your
I'll skip it.
choice of preposition.
How do you like
Not 4, but 2.
Yes.
I mean, to me, it's a testament to what people will put up with when they don't know there's anything better.
The beautiful reality is that this tool has enabled a bunch of musicians to make really interesting systems.
Yeah.
It works for them. And they don't have to learn a bunch of theory to do it.
Well,
So
works
we
looks
think
to
it's
me
worth
like,
it.
works looks to me like a strong word here. I mean, a system in which you sort of perturb
It's
the
a
whole
music
thing,
here.
and the whole thing just blows up and hard to diagnose.
I know that's the temptation, but if you do some
Why do I not get any sound?
YouTube videos, cool stuff with this tool. And with
Oh, yeah.
creative, which is.
So the question is it a testimony to how cool a paradigm this is, or a testimony to human ingenuity?
You're exactly right.
Sort of mission.
But without this tool, they wouldn't have gotten it done.
Yeah.
Well, it's interesting the comment about the opposite. I see each of the little components in here as being a little tiny block itself.
Well,
Yeah.
sure. I mean, flowcharts have been around for a long time, and I mean, certainly making them positional is not likely to make them better. But we know from the good old days we could program in flowcharts if we needed to. And the reason we used to program in flowcharts is because you weren't terribly symbolically sophisticated. It was supposed to be easier to understand.
Right.
For that. It's just too bad that they chose to implement these particular flowcharts in such a way that they seem even more fragile and error-prone than the old-fashioned ways.
So MSP is a little bit nicer. So you see these patch cords where they're dashed. So those are signals. Those are continuous signals.
Right.
And then you don't have the ordering problem.
Right.
All of a sudden. And
And for a musician who's used to plugging boxes together, this is arguably a very useful.
yeah. And then all the signal functions or objects, I guess, have tilde after them. So because it looks like a sine wave. So cycle sets up a cycle tone. One thing about this as opposed to functional reactive programming is that the continuous signals are only signals. It's like a floating point number it's just a floating point number. Like you can't have any other kind of objects, and they're designed to be used for audio signals.
Well, there
So
must
it's
be some way
very
to
constrained to
bind.
that domain.
There must be some kind of tuple so that you can do stereo, right?
Oh yeah.
Yeah.
Yeah, well, you can send, you send lists.
Yeah.
And
So there is
Well,
some.
lists are for Macs. MSP, you just have two channels, you have two wires.
Oh, it's always two. It's always two floating point
You can't-
numbers, one that's left and one that's right.
well, I think you can split the, you have two wires for the signal, but you can, but you can have like a box that has a list that's producing two discrete values and then transform that into two continuous signals.
But as soon as it becomes MSP, if I'm right.
Then it has
just
to be
one
split into separate.
Macs until
Yeah.
If you wanna go-
So there are interfaces. Yeah, there are things. Here's something that takes max inputs, like discrete inputs, and has a continuous output.
I see.
Yeah.
So if you want to do 5.1, you're kind of.
Yeah, I think so. So the idea here is these are different waveforms or different envelopes. Sorry. So it's saying hold it at full volume for 100 milliseconds, and then full volume for another 800 milliseconds, and then no volume after that. This one, that's kind of weird. Why is it 1? Anyway, it's setting up. No, it's not doing the multiplication, but it's setting parameters to this line object, and the line object is the idea is that you set it to a target, and then it gradually approaches the target. So I can say, if its current value is 0, I want it to have value 1 in 200 milliseconds. Then it will ramp up to it, and it outputs that as a continuous signal, which then goes into this multiplier.
Is that multiplier like a amplitude envelope?
The multiplier, it's multiplying they're all floating point numbers. It's multiplying two floating point numbers, but the idea is one represents the signal, the waveform signal, so it's amplitude. But the other one is it's like a volume control on it.
Yeah, if you took that envelope generator,
It's a fraction.
with the high frequency sine wave, the FM synthesis. And
Yep. Yeah, and you can totally do that in here, and that's what people use it a lot for.
So
And then this is playing all these notes together. It's playing 3 different waveforms that are overlapping. And you hit that button.
So for those of you who've used pure data, which I never really have, I mean, how different is this from PD?
My understanding is that they actually I've not used pure data extensively, but my understanding is that their roots are common for the actual source code that somehow, I don't know what came first, but this is actually, one is a fork together.
Okay.
Again, they're made by the same
So they should be pretty close.
Yeah. Conceptually, they're very similar, and I think
So-
the main differences, as I understand it, are the libraries that are available.
Oh.
But I might be something with it too. And I'm not an expert on it.
But I'm not. If I go home and start playing with PDs, I don't want to buy those. I should be pretty close to that.
This talk would be.
That's what I did was I downloaded the demo. So it's a 30-day trial. That's what you're seeing right here.
Northwide or someone has periodic workshops on pure data at the
Yeah.
Well, I think I'm going to wrap it up here so Phil has time to talk because I will have more next month and I can talk about Yampa then.
Okay.
Because it's very interesting. There's a lot more to research. I could just say briefly that it's similar to FRTime, but it's more sophisticated.
More Haskell.
Yeah, and more Haskell-y. There's more types on there and stuff, but it's pretty neat how you draw these little signal networks out of arrows. And the current implementation of FRTime, although it sounds like this is changing, but events are seen as continuous as well. Like it's just a value that at any point in time is either an event or a non-event. So most of the time it's a non-event, and then at certain points in time it has an event. So you can mix, but basically that way you can use the same combinators to work with events as you do with signals. But the trouble with Yampa is that it does have to sample. So you write something and then it has to sample every, I don't know how you control the sample rate, but everything on it is sampled. So even if you have events that are like GUI events that only happen every once in a while, it still has to constantly be
So
sampling.
it doesn't have a heat-based scheduler or something that actually keeps track of when the next change is going to happen.
No.
Steps forward.
No, but there's change in that direction. There's papers that I'm just starting to read that are about a cleaner separation between the discrete and the continuous. So
It seems like kind of the captain obvious thing to do, right? Is to like just
Yeah.
schedule.
yeah, agreed. So anybody have any other questions? This little chart I was starting to make of similar constructs between them.
So I mean, you've spent a week or 2 weeks or 3 weeks, some amount of time
Yeah.
expanding all this. Are you still enjoying yourself?
Yeah.
I mean, it's a fair question. I mean,
Yeah, I find it very interesting.
it is interesting, and it looks like something that's going to be productive to you.
Yeah, I'm just going to continue looking
Better
into
you than me.
Yampa. And,
I think your question needs to be qualified. It's definitely interesting to Lyle, but that doesn't.
Well, no, that's
that's what's important.
And other people.
Lyle and I are
That's
that semantically distant.
No, I'm-
The things that he finds interesting.
Yeah.
No, that was what I was trying to get a feel of. Is I've watched a lot of people poke at this, including myself, and
Mhm.
my reaction after a day of it was, "Wow, this is really hard, and it doesn't look all that productive." And then I wandered away. So I was wondering if I had failed to persist adequately.
Yeah, that's what I've noticed. I felt like the more I persisted at this, the more it started to make sense.
Of course, one version of that's called Stockholm syndrome, but but no, it looks like there's some cool stuff here.
It also sounds like having you mentioned productivity. So, like, for example, if one of your goals is to be able to like do music processing,
Yeah, or video. I
Right.
didn't show any of the video stuff,
then this seems to be a lot. Getting to productivity is
Yeah, being a
short
commercial,
path.
it's a polished
I've
commercial
written-
product that has a lot of interfaces to all sorts of equipment
Right.
and other software.
Yeah, I've written lazy audio processing in
Okay.
Haskell before, and so without using FRP, it'd be interesting at some point to sit down and sort of compare notes and approaches on sample problems.
There's well, if you. Oh right, so you're
It's
not
not going to be this. Not going to be the next 10 weeks.
Rats.
Well,
Yeah.
There's in-browser JavaScript libraries for if you want like a GUI for doing that data flowchart kind of stuff. And then like I put one of them on a data flow language. Just you move off, it just parses some config file that represents the and hit run or whatever, and it'll generate, say, some graphical language syntax for you out of the GUI.
Hmm. Cool. Yeah, maybe you can send us that on the list. Anything anybody mentioned during this time, I encourage you to send out information about it on the list so we can all review it.